why did you start, Usetech, background, that type of stuff. But how are you doing today?
Yes, we can start. Scientist. I'm not a data scientist. In Usetech, I'm working for the data science. I'm a leader of the department. But I have some, maybe more than 50 papers in Q1, Q2, in the asymptotics area, and about the data simulation in some ocean models. Maybe in UStack we create some new algorithms, digital twins for some processes in finance, in oil and gas, in energy, in power consumption, and more, and other more. We have maybe more than 20 successful projects a year. For 5 years, it's more than 100.
So let's take a step back and let's talk through what a digital twin is and why is it important for the average listener to understand.
Digital twin is maybe, from my point of view, it can be constructed by two ways. The first way is mathematical modeling of the process, and another way we can try to describe this process, maybe some features of this process by the ML models, and I have some example about it. In energy sector, we worked with oil refining company, and they had a model of distillation column. They have all the technical plan, and when we start, there is a wall, a bunch of some kind of heat exchangers, maybe another one, and in general, the way they have the digital twin, because they have all components, they have the mathematical modeling for them. But why they ask us to help them? They need to optimize this process, and they have 3 teams that achieved this goal in completely different ways, and we developed a system that optimize the approach of these different teams. As a result, one of team did not manage the installation optimality of this process, and they aimed at the output components of excellent quality while burning gas to head the fuel. And as a result, we construct the advisor model that recommends certain additional of certain components in this column and minimize the power consumption. That means that when we would like to come from point 1 to point B, we can use different ways. And we can modeling it by the digital twin. We need to think about how we do it. Artificial intelligence can help you to choose right way with minimal power consumption, minimal optimal quality of output products. So maybe another, and which way is best for some purpose.
Yeah, so what I hear you saying is that the digital twin is essentially a virtual type of environment in which you replicate a real world environment, and then you can maximize the efficiency of the energy, identify the best routes for that energy to run through, and then minimize expense or waste.
Actually, digital twin can help you in this approach, but we can compare it with ML models. And when you want to create the digital twin of some mechanism, you need maybe 1 year with a good skilled command of developers which make this product. But if you want another way, is constructed is with machine learning algorithms, maybe artificial intelligence algorithms, and you need maybe 3 months, 4 months to build not a digital twin. I call it statistical digital twin for some parameters of your process, which you can measure and which you need to provide good quality of your product.
Let's talk through what Usetech is and what are the primary missions of Usetech. And I know we started talking through the industries that you're kind of working in. But if you can talk about an overview of Usetech and why you're in the industry and what impact you're having.
We have more than 1,000 developers, software developers on board. In artificial intelligence department, we have more than 30 specialists with PhDs and other skills. We working with our main sectors where we work is finance. It's oil and gas companies, factories, chemicals factories, maybe pharmacy. And the other one where I'd say we have more than 2,000 successful projects in all areas where you can have in mind. And we are large and we help all of them. We have office in Dubai, in Serbia, we have international team in around the world, in Singapore.
And so with the growing importance of the data that's rising up and the importance of AI and machine learning, let's talk through how Usetech and you are using the AI to optimize your systems.
I will talk about the industrial companies. We create artificial, maybe some machine learning or AI algorithms in chemical sphere for power consumption, for fuel consumption, some optimization stories. We have the algorithms to detect. Maybe in computer vision to detect the bicycles or cyclers. Some in algorithms in power distribution systems and other more. We are working with two approach. Yeah, you want to say
in the power system? Is that in load balancing, or what challenges do you face in that?
In power system, we have successfully created the power optimization for solar beam systems. We make the balance of the voltage and in the whole system. And we have the platform where you can add some new source of your energy or electricity energy, and you can this system making the balancing and for you, and give only from your source electricity only on the sum which it can be given from you for you for the balancing of all system in the all net.
What are your thoughts on integrating the AI and any risks that come involved with that? Because I know there's a human element and there's always going to be a human element, but is there an increased risk in bringing in AI to the energy sector, or is it actually reducing the risk?
Yes, we think from my point of view, AI is a mathematical algorithm and some averaging. Thus, according to style of thinking, it's a rational algorithms, and the main risk is that it does not provide AI to make a decision of the process. We provide the theory where AI can maybe is advisor for the human, not only human can push some button, not AI.
Is there is the AI being optimized in the energy consumption, or is there a greenhouse effect in the sense of, is it going to release or reduce the carbon footprint and reduce global warming and have a long-term impact?
Actually, yes, AI can help us in this problem, because I think the mathematical model algorithms with artificial intelligence, because AI is optimization, and it's based on optimize some target, and if we would like to optimize the target of the carbon steps that the minimize of the carbon in power consumption. We can AI can help, can do it, but when is the minimum of energy will be turned off all our power station because the target is of carbon will be the zero.
I think that's a very noble and important goal to move to. I know you have a big working in gamification. Could you tell me what that is?
Gamification. Yes, we have a product in Usetech for it's called the Till and Char, and it's based on the gamification approach in teams. Its approach will the company give some bonuses, maybe coins for some uh, maybe participation of conference, participation in some repost, some posts in social media, social nets, and it help a company to explore, make some PR for company, and some members of board think that can help companies that making some new, maybe some new business maybe to deal. Yeah, it's a makes it as a company is not a team, it's a family, and this approach can help us.
When I first heard gamification, the first thing I thought was game theory, and maybe it had something to do with the AI and how to build the models. But in doing some
Yes,
research,
you in company in this project we create some another ways to get some prices or coins. It's came from game theory. It's called loot boxes. Maybe some and maybe one week ago, we create the additional of some. It's a game. You can make some. The pay for a ticket and open some loot box to find the price. No, some and maybe with logo of company, and it's a game.
I think this is more aligning more with the HR and trying to expand a business by providing a model in which you can reward your employees for doing their hard work. Although, many would say their reward should be a paycheck, but and even the system of creating badges or a system of virtual, like a video game where you have virtual badges and you're progressively getting better, you could use that to create your KPIs, your key performance indicators. And you could have your a social media rep have a goal to say, we will expand our social media presence by 100 people every month. And if you do that, then you get a badge. I think that's a very productive way to build a strong team. But let's go back to the AI and talk through some of the challenges that are faced with adopting AI. I think there's a cultural issue. There may be some cultural issues in adopting AI and integrating it at some of the senior levels. Do you see any cultural issues or any challenges in integrating some of the AI into your work?
Now we have a good experience with computer vision systems. We in granulometry, some other ways, and we uh, I I think it's my point of view that we need doesn't need to create the large neural nets to solve some problem. We can solve it by using our mind and machine learning algorithms. They're very simple algorithms because it's making maybe algorithm where we use in some industrial companies can be created with some ML, the decision trees with composition of decision trees and regression, and based on some feature modification from the data where you measure from sensors. And you does not need any perceptrons or neural nets to solve this problem. This system constructed by the ML algorithms is more open for investigation, and they knew about what we do with this data to make this target. When we use the neural network, we does not see the result, but we cannot knew how this result was calculated.
So moving to a different question, I think this would be a pretty fun one. List your top 3 models that you're using right now. So is it regression, linear regression? Is it clustering? Which one? What are your top 3 right now?
Top 3, all of them. The top 3 is the mail algorithms. It's trees, maybe some algorithms based on trees and regression. Another variant is transformers, because when you working with some NLP, some text, we need to use the transformers. And I think in computer vision, the best algorithms now for me for our area is UNet based, UNet architecture based.
Interesting. I always go back to linear regression. I think that's the most basic, and it's been around the longest, so it's easiest to use. What are your thoughts on linear regression and using it in your field to predict? Is what you're doing able to do prediction modeling for upcoming outages, or reverting or changing the path of the energy when there's peak hours?
When we use the linear regression, we can make some when we use it, we can solve at some maybe mathematical formulas and see that integrate with some of some features. Maybe sinus, the cube of sinus of some feature plus square of another features. And it's a linear regression because you the non-linearity you append on your features, not on your algorithm. We have the simple algorithm, but non-linear in features, and it can help us. For example, in power station, it works in some maybe stages, and for example, we can use the decision tree to detect on which configuration a power station work now, and after that we can use some maybe linear regression or another based on trees algorithms to calculate the power which can be generated or consumed, and another variant. Yeah.
One of the ideas I just thought about is using the AI to create your digital twins. Do you do that right now?
We can use we cannot use AI to create because it cannot help us. We can use AI to create some maybe some feature approach. It's maybe the statistical digital twin from start from your measurement data to predict some targets which you can measure on your system, or you saw on this data to make some decision about this process. And AI can help you to predict this data, and if these solutions can maybe some low effort, you does not need to create the digital twin in some special packets, special software, and other maybe you can use this approach.
What are your thoughts about a data scientist using AI to do data cleaning and data integration, data splitting?
Actually, we can use this approach to called automotive data cleaners, but This approach can it's only rational algorithms. Which features can you generate from the source data? It's maybe some linear sums with weights that look like the linear regression. Maybe some anomaly detection, but human saw this data. We can make some we knew some physical and chemical laws. And if we see on the data, we can make some feature manipulation, which does not make the AI-based algorithm because it does not know physical and chemical laws. Now I knew that for if you have simple approach, it can be done, but in other cases, we need to help from human to solve this problem.
Yeah, and so do you think that? So I know AI would be useful in repetitive tasks, and some of the data cleaning process is repetitive, but there's also the human error when you have an extra button typed or whatever you want to call it, copy and paste in the wrong place. It can get very complicated. The wrong script. How could AI help with that? Because what I see a lot of people doing is they may not necessarily be experts in Python, but now they're using AI to have the base code or the base script, excuse me, and now they can edit it and do some research. What are your thoughts on that?
I think yes. For the repeated process, we can use automatization, and it can be used by AI with large language models. Now can write some code, and in some variants it can be successful completed and working. It's a good idea, but when we use in science, we cannot. I think now we cannot use the AI algorithms to change our work because some human can find some solution where we cannot where an AI cannot solve it. For example, in maybe some algorithms where you need to make some decision based not on costs, based on feeling or on thinking.
Doing some research into Usetech, I've seen that you have over 80 turnkey cases across the industry. So could you explain what that is and what that means? And could you share some of the key milestones in those turnkey solutions?
Okay, I can tell about some cases. For example, we have a project when we recognized cyclists on the side of the road, or those who want to start crossing the road. And the reaction rate for the recognition system should be faster than 1 microsecond. And we have successfully done it. And now and not on the GPU's approach. We applied the data flow approach and we able to implement this algorithm with reaction less than 1 per thousand. And in fact, it turned out to be a new video chip detector for this system or for the cyclists. In another variant, we creating some, for computer vision projects. We create some galvanometry project. We detect the oversized stones on the trap. His accuracy it's near the one. It's 99% for oversize. And in medium, it will be the effort will be 5%. This is the mean effort for this case. Or maybe for chemical process, we have the successful solution to creation the dynamic evacuation plan when some happens on your factory, and it help people who working on the factory to go out from it with safety from go out, because without some problems, some taking and on the one place, it's safety evacuation.
So moving to a different topic, let's talk more about predictions and what you think. This is completely opinion, so we're just talking through your thoughts and your ideas. But where do you think will be in the next 5 years with the integration of AI? What impact will the AI have in 5 years?
I think we met the large language LLM models, which can solve some maybe new problems, the mathematical problems. I think and months ago we met some task from with the logic, and see that the Llama model solves this problem with some mathematical intellect here. I think if you talking about the AI algorithms, I think we can add some new approach in it's not it's I think it's element based. We came from the GPU's approach to from the control approach to data flow approach for training and fitting our models, because it's more convenient for training, and we have the problem when we train some on GPU, we need to start the same algorithm on all threads. In data flow approach, we can making some threads can solve one problem, and another thread in the same time can solve another problem, based on data, and therefore it's increasing. I see now we working with this approach. It increase this velocity of training for more than 10 or 100 costs. So maybe another way is decentralized learning. Its approach. Now we use centralized learning to train our model. We store data and resources, hardware to train the model. And for example, federated learning approach can help us, doesn't send data between between servers, and all servers, all clients trained model local, and send the model weights for server, and server aggregate these models.
So one of the topics I wanted to ask you about was, we talked through the effects that you could have on global warming in reducing the overall carbon emissions. One of the byproducts, and this is just a little back and forth, I don't think there's a right answer, but what are your thoughts on the amount of energy it takes to have the servers and have these server farms? Because the more data you have, the more servers you're going to need, which pools more energy and has a higher heat cost to keep those servers cooled down. What are your thoughts on that?
It's a big problem, because to train the models we need power, and its power will be generated from with carbon dioxide. Yes, and we we can for another way we can use some small uh, hardware. The decentralized learning can help you to make this, not to solve this problem, but minimize risks, and minimize power consumption for training, because you does not send the big data pools. You need send only small models. This approach can help, but it does not solve this problem.
I think this is a very big problem, but I think the work still needs to be done. I think AI is still a strong solution to help solve some of these problems. What are your thoughts on the critical functions of AI? I think this is very important to integrate into manufacturing and energy consumption. And I think this is going to help in the long run. But what are your challenges in scaling? So when integrating AI, I think you're mentioning do a decentralized approach in which everything is smaller. So now I want to ask, how do you start that? So you start out with a smaller AI, and how do you expand it across the enterprise?
We have a solution for it's a platform for federal learning, and on this platform we train the model for some health centers which store data locally, but the laws of this country cannot send client data from the medical center to another, maybe to another medical center, and this solution can help them. We detect heart attacks. We are analyzing some cardiograms. It's an analyzer, and we create some analyzer. It's a small model, and we train this model in all centers locally. The PCs, not supercomputer, and in our center with a server with it's will be computer with GPU where we aggregate this model, and we successfully solve this problem. And for energy, I think it's low energy we need. But if if we would like to get the all data from these centers, store it locally, and train the model, make more power for transfer this data between our server and clients. And I think we need more power for train locally this model. But in our experiments, the accuracy of the models will be the same.
And so I heard you mention the supercomputer. So I'm assuming you're talking through quantum computing. If you're talking through quantum computing, how big of an impact is that going to have? And will it be bigger once you have AI and quantum computing combined?
Quantum computing, it's a very interesting theory where we create algorithms in where we does not know anything about it. It generate all possible variants. It's infinity variants, and it's interesting that we have algorithms, maybe for some crypto algorithms, which based on this. The crypto securities stable algorithms to transfer data from one point to another point. I think now it's expensive toy. I think not maybe 100 years or 200 years after it, we can make the full quantum computer where we can try to modulate some AI approach. Now I think it's impossible. We have some, but it's a new and very perspective area for research and not for implement in fact.
I thought we were 10 to 20 years away. So if we're that far away, I'm relieved because I work in cybersecurity. And so I'm horrified by the quantum computing. I'm kind of scared with AI, with the AI integration. Here's some of the projects you're working on right now, and where can people find you, and how can people reach out to you?
Now we are working with a project it's a OCR project from Arabic language to it's from OCR from handwritten Arabic symbols, so some handwritten Arabic texts to maybe to voice, but the main some maybe some improved of this project is when the meet where we meet is that first of all it's written from the right to left, not from left to right, and that's one approach. One of
That's very telling.
yes, yes, it's another way. And another way, if you write in English, we use the same letters, but in Arabic it maths when depends on where letter is. If it's from the start of word or finish or internal, it's a different letters, and so that means that we from 28 or to 35 letters we met the matrix with maybe 200 variants for all handwritten letters, and I think it's a very good challenge for us, and we have the system which can recognize the text with accuracy of 90 to 93%. I think we can present it in JITEX at October. Yes, we have a very strong deadline for this research.